hub. Hub is a not intelligent device. Not intelligent device means it don't understand any MAC address, IP address. You just use it to connect devices. This Cisco packet tracer is not opening. But it will take a lot of time. Okay. So this is hub, how it is look like. It's a D-Link hub. So TP-Link hub is there, small hubs and there. Okay. So we are connecting our system. We can able to connect. Okay. We can, what is this? What is this? Not required. Not required. Okay. So we have a hub and we have a devices. So hub don't understand what is MAC address, what is IP address or anything. So I'm connecting these devices to our hub. For example, this is APC, BPC, CPC, DPC, EPC. Okay, it's a simple LAN communication, LAN connector. I want to send a packet from A to B communication. Okay, so packet will send to the hub to B and C and to D and to E also, because it don't know where is BPC. It will send to everyone. It will send to everyone in the network. Okay, so hub is a broadcast domain. It send packets to every device in the network. So for example, A want to send a packet to B. Hub A to hub to B, C, D, E, F. So the devices, those who are connected to the hub, will get the packet. And B is our destination, right? So B checks the MAC address and IP address, it accepts the packet. The remaining devices will drop the packet. Because so to address and from address is enough. To address means source A. Sorry, to address is destination, but is from A. Okay, guys, packet is always travel like this. So when B receives, it will verify, is it my MAC address? Is it my IP address? Like this. Yes means it will accept the packet. Okay. And for example, C received same packet. It's a B's MAC address and a B's IP address. So it's not my MAC address, not C's MAC address, C's MAC address. It will drop the packet. Something I'm not taking. And you are a completely 100% silent people. Is it people think silent of lambs? Don't breathe. I am getting that movies. Okay, the silent scene. Another season is there. Okay. Yeah, I'm not getting anything else. B accept the packet. Remaining devices drop the packet. So because of this, what will happen? For example, simultaneously, C send a packet to D. C to hub to D plus E plus A plus B. D accept the packet. Remaining drop the packet. Okay, drop the packet. What it is?
Okay, sir.
Okay, so wait. So what happened? So traffic will increases in the hub. More number unnecessary traffic, right? So the packet, same packet is also sent to others, means so many packets are traveling to and for kind of stuff. It means more traffic is generated, more collisions will occur at hub, more packet data loss is occurs with a hub. So that's why hub used for a small networks. If you have a 3-4 computers, so you can use hub, no problem. Okay, and we are using for a LAN communication. So hub is used for LAN communication and suitable for a small networks, because large number of devices you use it, more number of collisions will occur, more data loss. Okay, and a hub is an example for a layer 1 device as per the OSI. It is a physical layer device. It does not understand MAC address and IP address kind of concept. Next one is repeater. Repeater repeat the signal, so then signal can send to long distance. Signal can send to long distance. Okay. Normal signal is normally in a UTP STP cable communication support 100 meters. For example, I want to send this to my next device is around 150 meters. Yeah, 1 second, guys. Just be online. Okay, guys. Are you able to hear? Muted, unmuted?
Yes, sir.
Okay. I want to communicate long distance, not very long distance. Just my cable support up to 100 meters. But I have a device, the next device is at 150 meters. So signal strength is become weaker, right? Signal strength become weaker. So I use a repeater to repeat the signal. So it will repeat again. It means the signal again we can conduct another 100 meters. Okay, it is like that. So we can use hub as a repeater, and there is separate repeaters also there. Otherwise, you can use a hub also. Okay. Another example for repeater, because you may not seen repeater, but you have an idea about a Wi-Fi extender. Okay. So your Wi-Fi router is located in a hall. You are in some bedroom, but you are getting a very weak signal. Okay, you are getting a very weak signal. So what you will do? So you have to balance in between like a, okay, so you can use a Wi-Fi router, Wi-Fi extender to get the signal properly. Okay, so what you can able to use? So here it is in this diagram in this corner. Okay, Wi-Fi, for example, this is my Wi-Fi router where it is connected for internet. Okay, I sitting here. Okay, I'm not getting a proper signal, very less signal or no signal it is. So where this Wi-Fi router is giving a signal, okay, and we have to follow the distance in between. I should get a proper signal. So I will receive a signal and then I will redistribute the signal again. So this device is actually connected to this router. This is only to boost the signal only. It's not boosting exactly, say it repeats the signal, it receives the signal and repeat again. So then this device will get a proper signal. So that is a Wi-Fi router, sorry, Wi-Fi extender. You guys understand what is the use of Wi-Fi extender?
Yes, sir.
Yes, sir.
Yes, sir.
So next device we done hub, repeater, and next is switch. Switch is a intelligent device. Intelligent device means it understand MAC address. It learn the MAC addresses of connected devices. It maintain the MAC address table. I will explain that MAC address table kind of stuff, but few main points. Switch is also used for a LAN communication. It is a layer 2 as per OSI layers. It is a layer 2 device, DataLink Layer. Switch is used for both small and large networks. It means we can connect large number of devices, we can connect it. Normally hub have only 8 port switches. If you see hub having a less ports only, mostly not 8 to maximum 16 like that. So 8 ports are mostly common. Okay, this is 8 ports hubs. Okay, but if you take a switch like this, you take a switch, switches are both small size switches are there. It means 8 port switches are there, 16 port switches also there. Okay, you can get like that. So bigger connecting switches also, not this one, this is wrong. Okay, both are switches only. Okay, depends upon type of switch, guys. Manageable switches, non-manageable switches. This is how the switches look like. So multiple ports are there. Okay, multiple ports are there. Okay, so this is few points about a switch again. So it is used for LAN communication only. It is layer 2 device, data link layer, used for both small and large networks. Okay, this is understand MAC address and create a MAC address table. Plus I am going to draw that one. So carefully listen. Okay, because it's only one shot explanation. I don't repeat this explanation again. So there is a devices are connected to a switch. This is how devices are connected to a switch. Okay. This is 8 port switch, for example, first port, second port, third port, fourth port, 5, 6, 7, 8 ports it is. This is PCA, B, C, D, E, F. Okay. So there is every PC has their own MAC address, right? A PC has a MAC address, B PC has a MAC address, not PC, NIC, where we are connecting this NIC, that's connectivity, this NIC has a MAC address. And every PC must have an IP address to communicate. Every PC must have an IP address to communicate. And every NIC must have a MAC address because of its NIC. MAC address is a physical address, physical identification of a device. Okay. Every device has a MAC address. Guys, remember when you are sending a packet, along with the data, there is certain addresses. Your sending means source MAC address, source IP address, destination MAC address, destination IP address. Okay. For example, I'm sending a packet from A to B. Again, A to B. Switch act like a hub initially.
Yeah.
Okay. Switch initially broadcast packets means it send a packets to every device like a hub initially. So what will happen? A send a packet to the switch. Switch will send a packet to B because it don't know where is the BPC. And it send a packets to all other devices. B accept the packet, remaining drop the packet because there are not their own address. Okay. So A send a packet, right? So here it is. While sending, what is source MAC address? A's MAC address, A's IP address, B's MAC address, B's IP address. This is important, guys. Try to understand this MAC address, IP address, source IP, destination IP. Okay. So switch received. This is my switch. Switch received this addressing. Switch understand MAC address. Switch understand MAC address. So what it will create? It will create a MAC address table. In this table, device MAC address and their port number, switch port number. Port number 1. This is port number 1, right? Port number 1 received a packet from A. Port number 1 received a packet from A. You can see from A it received a packet. So what is that packet contains source MAC address? Whose MAC address it is? A's MAC address. Very good. So what it will do, it maps like this. A's MAC address, port number 1. Okay. Of course it do broadcast, but it do parallelly it creating this table. For example, C send a packet to D. So again C2 port number 3 of switch, from there again broadcast to everyone.
Sir,
Yeah, tell me.
every port has different MAC address.
Every device have a different MAC address.
No, sir. In switch, every port I am asking.
No, no, no. Switch have a port, but not MAC address.
Okay, sir.
Okay. But switch is connected to device. Yeah, it is working now. Look at this is my switch. This is my devices. And I'm connecting. So I have to connect with the straight through cable. Yes, this is from this Ethernet port to this. Okay. Okay, so I connected the devices and I have to configure IP address. First PC I'm configuring IP address. It's simple IP address. To communicate in the network, compulsory device must have a IP address. Okay, device is having a IP address now. So this is my switch. Okay, what happened in a search? So this is inside a search. There is no MAC address table. MAC address table is not created. Okay. Now I want to send a packet from this PC to this PC. So in a simulation manner, I'm sending. So we need a packet. And this is the destination. Okay, guys, look at what happened. I'm sending from here to here. Okay, so this is, you don't know the destination MAC address. So it is showing FFF as a destination. Source is this PC MAC address, destination MAC address, source IP address, destination IP address. It's sending. It's sent to the search. It is at search. It is showing source, destination, source IP, destination IP address. Okay. Now it is sending to everyone. And these two are dropped. Why these two are dropped? It is not belongs to them. Okay, it is not belongs to them. And this is, look at, it is received a packet. It learned the MAC address also. Okay, now every sending there is a reply, means from destination to source you'll get a reply, right? So now it is sending to the search. Okay, wait, we forget one thing to check it. MAC address table. It already learned two things. This is the MAC address of first device 00E0 A3E170 3D. Okay, so I will check its MAC address. It's not showing here. Yeah, can you see? This is the MAC address of first
Yes,
device.
sir.
Okay, second device MAC address also it is learned. So second device MAC address 000 BED1 BA9 something it is showing. So where is the switch? Yeah, this is because we already done one step additionally. So that's a device where it is connected. Can you see port and MAC address? Okay. So switch learns the MAC address whenever data is transmitted, that is received a packet. Okay. So now switch having two MAC addresses. What about remaining devices MAC addresses? Why these MAC addresses are not came?
Yes, sir.
I have 4 devices, 4 MAC addresses should be listed now here,
Yes, sir.
but it is showing only 2 MAC addresses. Because of?
Because we are sending packet to B only.
We are communicating between these two only. Very good. For example, I am sending a packet from here to here. From here to here. Okay. Now packet received. Then we'll see MAC address. See third MAC address. The device is MAC address. This is the new MAC address is added here. 0060. So when there are sending a package 00605647. So when you are sending a packet, so your source MAC address is connected, right? So it will map to your switch port number. It maps to that switch port number and the MAC address of a connected device. Okay, so this is simulation. Okay, this is how MAC address is created. In this example, I am showing C2D. It means first C's MAC address. Okay, C's MAC address, C IP address, D's MAC address, D IP address. So where is the port number? Port number 3. Port number is 3. And C's MAC address. C is connected. C MAC address. Okay, like it will be created. I'll show you one last kind of stuff, guys. This contain 3 MAC addresses, right? What I'm doing is I showed all broadcasting type only. Now I will show you unicast. From this PC to this PC, we are sending a packet from here to here. Okay, from here to here. Okay, source IP, destination IP, layer 3 protocol. Packet sent. So what is the packet contains? So it is showing source IP, destination IP, but still it is does not know about this MAC address. Broadcast, unicast, communication done. So again I'm sending from here to here. So we know both source address, destination address, source MAC address, destination MAC address from here to here. Packet send. Now see properly, guys. It's not sent to remaining 2. It's sent to that PC only. How? Because of
Because we are sending only to that PC.
it knows destination MAC address, and destination MAC address is at port number, this port number 0/4. So it forward the packet to that port number only. Okay, so like this,
Sir,
you want to send a packet to C. Yeah, tell me.
sir, who provide MAC address, sir?
On your NIC, you have a laptop or a desktop. You have NIC to connect to network, either wired or wireless. Your mobile phone, Wi-Fi is there now. It is also having MAC address. It is given by manufacturer of NIC.
Okay.
Okay, so D-Link is one of the manufacturer, Realtek, Qualcomm, Intel. There are different manufacturers are there. So they will assign a MAC address. Its MAC address is a physical address. Okay, guys. Now I want to communicate from A to C. A to C. Okay. So what is source? Yes, MAC address. Yes, IP address. Destination? C's MAC address. C's IP address. Where is C's MAC address? Here. Where is which port it is connected? Port number 3. So what it will do? A send a packet to the port number 1 and switch check the MAC address table. What is the destination MAC address? Destination MAC address is C's MAC address, which is at port number 3. So based on that table, it's sent to the port number 3 and it will be sent to C direct. It is not required to broadcast. It will unicast the packets using MAC address table. Okay. So switch initially broadcast means send packet to everyone, every device which is connected in the network like a hub. Switch verifies the MAC address table against the destination MAC address, which is mapped to port number, and finds, if it finds, send packet to the port number. Means unicast. Okay. First, it learn the MAC addresses of a devices connected and map it to the port number of switch. How it can able to do that one? So when devices are communicating each other, so that time it learn the source MAC address of a packet and the port number it maps. Okay, it uses this MAC address table to the unicast. Because of this one, number of drops are reduced. It is not required to send always to B, C, D, E, F, A to B, but packet is sent to A to B only, not required to send C, D, E, F. So, number of unnecessary packets traveling through such number of collisions will be reduces, number of drops will be reduces, so number of traffic will be reduces. That's why switch is suitable for both small and as well as a large or very large networks also. Okay, guys, understand somewhat functions of a switch?
Yes, sir.
Yes, sir.
Yeah, tell me. Okay, so switch, there is a layer 3 switch is there, guys. Switch is a layer 2 device. Remember, switch is a layer 2 device, but there is a layer 3 device, layer 3 switch. It works like a both switch and as well as a router. Layer 3 switch. Okay, so layer 3 switches are used for both. It's kind of what we can say. It works as a router as well as a switch. It works as a router and as well as a switch. Just in case in future, maybe if someone asks what is the layer 3 switch, don't worry. Switch is a layer 2 device. Router is a layer 3 device. So layer 3 switch function as a layer switch as well as a router used for a inter VLAN routing, VTP, inter-network communication kind of stuff. The next one is router. Before going to the router, guys, I am going to tell one small difference between hub and switches, because both are in a LAN communications. Always, guys, what it is. First day only I told what it is and what is the difference between this and what is the difference between that. Hub and switch, switch and router, hub and router, router and modem, switch and modem, different kind of stuff. Okay, so always go with the basic differences. Next, if you want, go with the functionality differences. Okay, what is the difference? Hub and switches, both are work for a LAN communication. Hub is used for a small networks, whereas switch is used for a small and large networks. Hub is a layer 1 device, switch is a layer 2 device. Hub broadcasts packets to every device in the network, and switch initially it broadcasts packets to every device in the network, but later it uses a MAC address table to unicast the packets. Hub don't understand MAC address and IP address, but switch can understand MAC address. Okay, and it creates a MAC address table. Number of collisions are less in switches. That's what we are using for a larger networks. That is enough. Okay, one line is there. That line I removed okay, recently from last class. I think so. Okay. Okay, guys. Next is router. Okay, hub and switches.
Yes, sir.
Only two things. One is router. Next one is modem. Okay. Then there is a one difference between ping and trace RT command. I will tell. Okay. Few points. I will add it. See. The router. Router is a intelligent device. Router works with a logical addressing. Router is also intelligent device, but router is works with a logical addressing, means IP address kind stuff. A router is a inter-networking device. Router is a inter-networking device. Router used to connect to or more networks, different networks, to or more different networks, to or more different networks. What is inter-networking? Communication between different networks. So router connects to or more different networks. Router used for both LAN and WAN communication. You can see this is a one LAN, this is another LAN. Router is in between these two LANs. Okay, not only like this, you can see this picture which is I draw using this packet tracer only and my drawing skills only. You can see this is one LAN network, this is another LAN network, this is another LAN network. These different LANs are able to communicate each other through the WAN. Okay, how we can connect? Through the routers. To the routers. Okay, for example, I am here in this place. I'm located in this place. Okay, it's not that. I want to communicate to this device. I want to communicate from here to here. How to communicate? I have to send a packet to the switch or a hub to the router. Router understand what is my destination. It will forward the packets towards the destination, and the packet is traveled and reach the destination. So when this one want to reply, then again it will go back to this router and again it will tell how to reach the destination. The router is layer 3 device. Okay, apart that's thing. Okay, yeah, already I told. So it means, guys, what is router? It is not router. Actually it is router. Router means path. Router means path. Route means path, right? Router means it shows best path to reach the destination. How to reach the destination. Routers using routing tables to know how to reach the destination. Routers use routing tables to know how to reach the destination. Okay, so routers use routing tables to get to know how to reach the destination. I put a 2 times of same line in a different way. Okay, it means these routers are having a routing table. Routing table means which network is located in a which direction. That is a routing table. Okay, so based on routing table, you will understand the how can we reach the destination. How can we reach the destination? Router shows best path to reach the destination. Okay. Next. Modem don't have much lines, but modem is very important to explain. Already you know, guys, already all these things we discussed in the last class. So somewhere we are disconnecting where it is. Yeah, these routing tables are created manually. So you can create a routing table. Okay, you can create a routing table manually, or you can make it create automatically. So this is my router and this is my LAN network. Just I want to connect from my LAN to my router Ethernet. So this is entirely Ethernet communication. Now this is one network. This one is one network, but it has to connect outside of different networks, right? How it will be connect? So outside there is so many routers, okay, and different type of networks are there. So they follow a WAN connectivity type. This is a small router. It is, you can see. And this, where is switch? Yeah, off. Which one is 0? Yes. See, auxiliary cable, console connector. This is for LAN connection purpose. This is WAN connectivity purpose. I inserted a WAN interface cards. 2 serial ports it is. Okay, for this one also WAN connectors are required. I am using this type of WAN connector. WAN interface cards for connecting WAN. It's somewhere located. I need a WAN connectivity. Like this. Same way, these are also will connect. Okay. So this is LAN side. This is WAN side. I want to reach from here to here. I want to reach from here to here. What I have to do? Send packet from here to here, and this will decide how to reach this destination. Okay, so how it will understand how to reach the destination using routing tables. These routing tables can be created manually, that is called static routing, and these routing tables can be created automatically by using routing protocols called a dynamic routing. What are these dynamic routing protocols? Are RIP, AIGRP, OSPF, and of course EGP type is there, that is BGP ISIS. Means interior gateway protocols, exterior gateway protocols also there. I am not going to that much depth, but understand what is the use of router. Guys, again, a difference between hub and switch to the router. Router works with the logical addressing, and switch is working with the MAC address, means physical address. Logical addressing means usually IP address. Switch used in a LAN communication, router use in both LAN and WAN communications. Switch is a single network communication, single segment type of communication. Router is internetworking. It means it make a communication between different networks. Okay, switch is a layer 2 device, hub is a layer 1 device, router is a layer 3 device. Router uses a routing path to reach the destination. Router shows how to reach the destination. That's it. Okay, guys, up to here.
Yes, sir.
Yes, sir.
Next one is modem, modulator and demodulator. Modulator and demodulator. In our network, in our LAN communication, okay, in our LAN communication, the signal is usually in a digital form of signal. Digital form of signal. It is not, okay, not signal. So normally digital form of signal represent like this. Means low level, low strength signal it is. It is for a LAN purpose only. But you have to connect it to internet. It means your ISP is located somewhere in the place, right? It's difference is there. No, it's not in your at your building. He's the ISP provider is located in very longer distances. Okay, and the signal, your signal cannot be reached up to your ISP. So what you have to do it? So one is for connectivity from your network to ISP, we need to connect with the telephone cables or a fiber optical cables. Second one is the telephone and fiber optical cable signaling is different, and outside communication is compulsory, different type of signal communication, because you have to send for longer distances. So we need to convert your digital signal to analog signal and passes through your telephone cables or a fiber optical cable. So what are the network you are using here? Okay, you have to go through this modem only. So modem convert your digital signal to analog signal. Modem connects you to ISP for internet. Modem send your username and password and connectivity type to your ISP. ISP verifies your authenticity. Verify, authenticate your connectivity and give the internet to you. Okay, it's enable internet connectivity. So you are getting internet up to modem, from modem to your network. Okay, so you want to get connected to internet, you want to get connected to ISP through your telephone cable or fiber optic cable, we need a modem. So why I have written this one, guys? Simple to understand. Modem means modulator and demodulator. The regular voice signal is from 20 to 20 kilohertz frequency only. But you go to the FM radio, you can see the FM radio 93.5, 98.3, 104, okay, 102, 101. This kind of stuff is there, no? That is megahertz frequency. You tune it, you will hear certain channel. How it is? So in a frequency modulation, they add a high frequency signal to your regular frequency, your regular baseband signal, and transmit. Okay, so that is an example for a modem. But here in our modem, so we are used to connect internet. Modem connects to internet and stuff. Maybe in your home network, already I told this one, you may not see in your modem kind of stuff because your router having a built-in modem inside. That's so we can able to connect it. Just before I showed, that is Geo fiber optical cable kind of stuff. Okay, Geo router, it is Wi-Fi router, but it is also contain built-in modem where your username password is stored and connectivity to your ISP. Okay guys, that is a modem. Modem is a this side. Okay, so modem, router, switch, and your Wi-Fi kind of stuff. Okay, so this is also one interview they ask question where modem is located. Okay, it's between your ISP WAN connectivity to your router between that one. Okay, in our home Wi-Fi routers, it has a built-in Wi-Fi router. Some people, for some type of connectivities, it is separated. Modem, in certain organizations, certain type of connectivities, what they will do, they will separate it. For fiber optical one modem, they use it. From that one, you can connect a Wi-Fi router and you can distribute the internet through wirelessly. Okay. Yeah, you can try all these pictures so you will understand somewhat. See, it is a modem, it is a router, and we are connecting. It's not correct one, not this purpose, but for understanding, we'll try. Okay, guys, up to you now. Hello.
Yes, sir.
What happened, guys? You have to make
Yes,
some
sir.
doubt, no doubt, not getting.
No doubt, sir.
Okay, good. Guys, two commands I will tell, very important commands. One is ping, another one is traceRT. Okay, ping is a command tells your device is able to communicate with a destination. For example, I have a APC, BPC. A is trying to ping to B to test connectivity between A to B. So what is a ping command? Use it to test the connectivity between the devices. I want to test from A to B communication. At B, in a command prompt, I am trying to ping B. This one. So I'm getting reply from destination IP address means connectivity is there. From A to B, B to A, connectivity is clear. So you want to check it once again. So we'll try. Forget about remaining things. How to delete So new one, this is actually not as our old one, it is being problem. Yes. Oh, no problem. Very good. Okay. So what is this IP address? It is 10.0.0.11 and this IP address is 10.0.0.12. Okay. So what I'm doing is I'm going to command prompt and pinging to 10.0.0.12. So I am just waiting to get a reply from my destination. Now I am not getting. I think it is in simulation mode. Sorry. Okay. So I am pinging to 10.0.0.12. I am getting reply from 10.0.0.12. Means from this PC to this PC connectivity is there from 11 to 12 means from this PC 0 to PC 1 connectivity is available, connectivity is there. A to B, B to A connectivity is there. Now I'm pinging to 10.0.0.15. Okay. No, it's not in installation. No, this one. I'm getting a request timed out. It is searching for that IP address where it is located. So it's showing that's request timed out. It means the 10.0.0.15 system may not be available. Maybe I entered a wrong IP address. Maybe the destination device firewall is block your communication. Comes a time on the time. Okay. Now I am getting reply from 14. 14 is available, 15 is not available. I'm giving different network.
Not available.
It is not available. Okay, guys, see this. So if you got reply from destination means communication is clear from A to B, B to A. Okay.
Okay, sir.
So what is the ping command? To test the connectivity between the devices. So one more command is there that is called a Tracert. So ping command will tell you can you able to communicate between the devices? Can you able to reach the destination or not? Can you able to reach the destination or not? Okay, but Tracert will tell us how you reach the destination, means the path. How you reach the destination. So I given Tracert www.google.com. So then how I'm getting, I will show you. Here. So both I will show you. Go to command prompt. Okay, first is can I able to reach google.com? So what I have to do? Ping. Guys, I don't know IP address of google.com. So request go to my DNS server. DNS servers give me a first IP address of www.google.com, then ping. Okay, so it is first I got an IP address of google.com and I get a reply from that IP address. It means from my device to www.google.com server, communication is there. Okay, but I don't know because google.com not in my network, right? Google.com not located in my network. So I want to know how I reach this google.com server. It's located in somewhere in this world. We don't know. But I reached it. But how I reach? So I use a tracert command to know how you reach the destination. Okay. So first of all, from my laptop to my default gateway to my ISP to their other router to other router, other router to other router. Finally, we reach the destination. Okay. So like this, from my laptop to my router, my gateway to my ISP to in the world there is a lot of routers are there because of what is internet? Networks of network. What is internet? Net means it's a lot of connectivities are there, no? So networks of network, internet. Okay. So it is connected to one router to another router, other router. Finally, we reach the destination. How you know how you reach the destination? Based on Tracert command. How my system knows how to reach the destination? Because of the routers in between. See, I reach the destination in 8 steps. First step is from my laptop to my gateway to ISP to some other routers. Finally, I reach my destination. Let's understand difference between ping and Tracert.
Yes, sir.
Yes, sir.
I think I am given these things. If you ping to destination IP address, you got a reply from destination IP. You got a reply from destination IP address means connectivity is good. So look at here, I'm trying to ping to certain device, getting reply from destination means connectivity is good. If I'm getting destination host unreachable, so you can see I try to ping to a device, it is showing destination device host not reachable. Destination host not reachable. It means either this device is not available, maybe it is a wrong IP address, or device is disconnected. Either device is disconnected or you are giving wrong IP address or device is down. Sometimes you will get a request timed out. You are trying to ping to the destination, but you are getting a request timed out. Possibilities again, device is down or wrong IP, device is disconnected, firewall is your block or path is not available. Sometimes destination, the firewall is block your network, means you are reach the destination, but firewall is not allowed to access. So not allowed to deliver the packet. So then what it will do? Destination request timed out. You'll get a request timed out. Okay guys, just read these things. We'll see. Next. Okay.
Yes, sir.
Okay, sir.
Next class